Okay, this is the second page of the first set of notes. Starting off here with a couple of special cases, horizontal lines and vertical lines. Now, like it says here, horizontal lines are in the form y equals b, where b is a constant. Constant is just a fancy word for a number. So we got y equals some number, like this equation here, y equals 2. Okay, well, what's that line look like? Well, in our line, we know y is always going to equal 2. So that means every point on this line is going to look something like this. It's going to be something comma 2, where this is going to be some other x value. Okay, so what could that look like? Well, let's look at a couple points, something comma 2, something else comma 2. What could our x value be? Well, it could be anything as long as y is 2. So it could be, 0 comma 2, 2 comma 2, and then, we can put more examples, but since we're drawing a line, we know that that's all we need is 2 points. Well, let's plot those 2 points. 0 comma 2 is right here. 2 comma 2, we're going to go over 2 up 2. And we got those 2 points there. And then we can draw our line. And when we connect those dots, we see that we get a horizontal line. Okay? And then just double check, does that look right? Well, according to this equation, every point on our line should have a y value of 2. So this is, 2 comma 2, 4 comma 2, negative 3 comma 2. Yeah, no matter where I go on this line, no matter how far left or right I go, my y value is always 2. So it looks good. Okay. Next, vertical lines. Here, every point on our line has to have an x value of negative 3. Well, then what's that going to look like? Well, it's going to look like negative 3 comma some y value. Okay, well, let's throw a couple points on there so we don't have to think too hard. We know we're going to have negative 3 comma something and negative 3 comma something else. And then pick any 2 y values you want as long as x is negative 3. So we can say, let's do negative 3 comma 5 and negative 3 comma negative 1 maybe. How about those? Okay, so let's see. I'm going to go back 3, up 5. Got that point there. And then back 3. Down 1, that puts me there. And again, since we're drawing a line, we only need those 2 points. And now when I connect the dots, well, now I get a vertical line. And let's see, no matter how far up or down I go, what do all these points have in common? Well, anywhere on this line, x is negative 3. And that's what we wanted to draw. So it's kind of the opposite of what you think. Y goes up and down, x goes left and right. But for the equation of these lines, it's the opposite. Y equals is going to produce a horizontal line, and x equals is going to produce a vertical line. Okay. All right. Next, we've got the domain and range. Okay, so domain and range is something you've dealt with before. Domain is basically telling us what our x values can be, and the range, they want to know what can our y values be. Okay. So domain and range, the way I like to remember it, D comes before R, X comes before Y. So domain is the X values, the range is the Y values. Those are easy to mix up. Now, domain and range is not a hard concept, but they want us to write it in a way that we're not super familiar with. Hopefully you learned interval notation in Math 2 last year, but in case you didn't, we're going to go over that. Okay. In fact, before we do, let's look at some rules for interval notation. Like it says here, you want to use brackets when you want to include the endpoint. Okay, so for example, if it's a solid point like it is here, we're including that point. So then we want to use brackets around that number. Use parentheses when you do not want to include the endpoint. So here, we're starting at an open circle. We don't want to count that point. We just want everything to the right of it. So that's when we would use parentheses. Always use parentheses for plus or minus infinity. So if it's positive infinity or negative infinity, always use parentheses because, well, are we including the point infinity? Can we ever reach infinity? Well, no, because infinity is not a number. It's just the concept that the number keeps getting bigger and bigger and bigger. Okay, so always parentheses around infinity. And then we always want the smaller number labeled first and then the larger number labeled second. And then if we ever have to connect two intervals, we want to use this little U for union. And you will see that in a minute. Well, let's start up here with the first one. All right, so we want to find the domain and the range for this parabola. Okay, now one of the tricky parts, not tricky, but something we got to keep in mind is there's different ways to write the domain and range. Let's look at a couple ways and then we'll kind of stick to one way after that. So the domain, I'm going to put a D out here so we know it's for the domain. What is the domain of this parabola? Okay, well, when does it stop going to the left? Well, never. It goes down and left forever, and it goes down and to the right forever. So since this goes to the left forever and to the right forever, well, our domain is, well, x can be anything. And then how do we write that? Okay, well, one way to write that, we can say that x is greater than negative infinity, and it's also less than positive infinity. Okay, so this is how we've written it in the past, but now we want to also write it in interval notation. I'm probably going to be really tight on space here, so let me switch colors so we can maybe keep them closer together. The way we'd write that in interval notation, now since we're dealing with infinity, I want to use parentheses. Okay, and then what do our x values go from? Well, they go from negative infinity, that's the smallest number, up to the biggest number, which is positive infinity. And then we would close parentheses. Okay? So these are two different ways to write the domain. They both mean the same thing. Now, another way you can write it is, well, what can x be? Well, all real numbers. So a way to write that symbol is like an R with two vertical bars. Okay, so that little symbol there means all reals. So all three of these things mean the same thing. It's just different ways of writing the same thing. What we're going to focus on for the rest of the examples is interval notation, because sometimes they give you the option you can write it in either form. Sometimes they want it specifically in interval notation. So since this is the one they're going to want specifically sometimes, this is how we're going to write the domain and range on the rest of these examples. Okay, because we don't have space to write it both ways. All right, and then how about the range? What is the range of my graph? So in other words, what can my y values be? Well, just look at your graph. What can y be? Well, anything from this point down. Okay, so the way we used to write that, we would say y is less than or equal to what point? Well, this highest point has a y value of 3, so y is less than or equal to 3. That would be fine, but in interval notation, how would we write that? Well, in interval notation, we would say, so again, we want the lowest number first. So what's the lowest y value here? Well, it goes down forever, so it goes down to negative infinity. And then that goes up to what point? Well, the highest point on our graph is 3. Now, are we including 3? Well, sure, because it's a solid point on there. Y can actually equal 3. So then we want to put brackets around the 3, and then that's how we would write the range. Okay? So from now on, we're just going to write the domain and range in interval notation so we don't run out of space. Okay? All right. For the next one, we've got an absolute value function. So what is my domain for the absolute value function? Well, it goes to the left forever and it goes to the right forever. So the domain would be all reals. In other words, it goes from negative infinity to positive infinity. We can never reach infinity, so we use parentheses around infinity always. Okay, that's going to be the domain for a lot of the graphs, so that's kind of easy. And then what's the range? Okay, well, for the range, just look at your graph. What can y be? Well, anything from this point or higher. So this is our lowest point, which has a y value of -4. So my graph, my y values, I should say, go from -4 up to, well, infinity. It never stops going up. We can never reach infinity, so we want parentheses around that. And then can y actually equal -4? Well, yes, it can. So then we want brackets around that. Okay. All right, next one. In fact, let me zoom in a little bit. Maybe that'll help you guys out. Okay, next one. We have an exponential growth function. So first of all, what is my domain? When does my graph stop going to the left? Well, never. Now you might think, well, then it would cross that. Well, no, it's not. It's just going to keep getting closer and closer and closer to that line. Think of it this way. If we cut the distance between a point and that line in half, well, could I cut it in half again? Sure, and then cut that distance in half? Yeah, and then cut that distance in half? Yeah, and we could do that forever, and it would never reach this line. It would just get closer and closer and closer. So anyways, it goes to the left forever. Does it ever stop going to the right? Well, it's going up a heck of a lot faster, but no, it never stops going to the right. So again, my domain is all reals. In other words, it goes from negative infinity to positive infinity. And we can't ever reach infinity, so then parentheses around those. What is my range? Okay, well, what's the smallest y value on my graph? Well, it's getting closer and closer and closer to this line, which has a y value of what? -1, 2, 3, 4, 5. So it's going to be really close to -5. Do we ever actually reach -5? Are we using -5? Not quite, so that's when we want parentheses there, because it never actually reaches -5, it just gets closer and closer. In other words, we want everything above -5 up to what? Well, it goes up forever, so up to infinity. Okay, and there's the domain and range for that one in interval notation. And then last one on this row up here, a line. Let's see, it goes left and right forever, it goes up and down forever. So both the domain and range are going to be from -infinity to positive infinity, because they cover all values of x and y. Okay, so lines are easy. All right, and then on the bottom, the graphs start to get a little bit trickier. Okay, on that bottom row, we got to pay attention to a few more details here. Now, I don't care if it changes from a parabola to a line as long as they're connected with a solid dot like that. But I do need to pay attention to the open dots, especially in the middle of my graph. All right, so first, what can I'm going to start it way on the outside here. What is my domain? What can my x's be? Again, in interval notation, we want to start with the smallest x value, the smallest number. So what's my smallest x value? Well, it's the furthest left point over here. So this has an x value of -1, 2, 3, 4, 5. So we start at -5. Can x actually equal -5? Well, no, because it's an open circle. We only want stuff bigger than -5. So then we want parentheses around the -5. And then does it go all the way to 1, 2, 3, 4, 5, 6? Well, not quite, because there's an open circle here. So my x values go from -5 to +2. And it can't be +2 because there's an open circle there. But that's not all of our graph. So then we want to union that with these points here. So x values from 2 to 6, I think. 1, 2, 3, 4, 5, 6. Yeah. So from 2, not including 2, to 6. Now, since this is a closed circle, then yeah, we do want brackets around the 6 there. In other words, x can be anything from -5 up to 2, but not including 2. Then you kind of jump over 2 and start on the positive side, and then go to +6. Okay, so then that's how we would union those two pieces of the graph. All right, and then what about my range? What is my range for this problem? So what can my y values be? And again, we want to start with the lowest value. So my lowest point on my graph would be right here at a y value of -1. Well, that's an open circle, so then I can't put brackets on that. We need to use parentheses. And then my y values go up to what? Well, my highest point is up here at a +1, 2, 3, 4, 5, 6. So does it go from -1 to 6? Yeah, it does. Now you might be thinking, well, there's an open circle here. Well, that means that y can't be 2 at that point. But can y be 2? Well, sure, it's 2 right here, and it's also 2 somewhere right over here. Okay, so we don't have to worry about that open circle because, well, yeah, y can be 2 somewhere else. Okay, so it does go from -1 to 6, and yes, it can be 6. So then that's the range. Because again, my y values can be anything from there to there. Okay, so again, it can't be 2 here, but it can be 2 other places. Okay, so that's that one. Let's see, 3 more to go. Next one, what is my domain for this graph? So again, we want to start with our smallest number, which for the domain is the furthest left point. Well, this goes left forever, so then that's going to be -infinity. Up to what? So if we're coming down this graph, we're going to come down, we're going to stop here because there's an open circle. So we go from -infinity to -2, not including -2. And then union with, we also want this section here and here. So it goes from -infinity to -2, got to jump over -2, and then it keeps going to 1, 2, 3, 4, 5. So from -2 to 5, open circle, so parentheses around -2, open circle, parentheses again around 5. Okay? All right, and then the range for this one. What is my range? What's my lowest point on my graph? That's where I want to start with the range. Well, that'd be right here at, I think, -5 again. Yep, -5. It's an open circle, so we want parentheses around that, comma. And then my y values go from -5 up to what? What's my highest point on my graph? Well, this arrow means it keeps going up forever, so it goes all the way up to infinity. Now again, we don't need to worry about that open circle. This says that y can't be -1 here, but y can be -1 all along this line and somewhere over here. So we don't have to worry about that open circle for the range. Okay? All right, almost done. 2 more to go on this page. Next, what's the domain and range for this funny looking graph? All right, let's see. Start with domain. What is my smallest x value? Now, if we look closely at this graph, it curves here, and then it looks like this dotted line is an asymptote, in other words, a boundary line. So it's going to approach that boundary line, but never reach it, which means it's going to go to the left forever. So that's going to be from -infinity up to, well, let's see, it has a hole here, so we got to go to that x value, which is -2. Always parentheses around -infinity. And since it's an open circle, parentheses around -2. And then we want to union that with everything from -2 up until, when's it stop going to the right? Well, never, because that arrow goes down and to the right forever. So -2 to +infinity. A little tight on space there, but we can squeeze that in. And then the range. Well, what's the range for this graph? What's my lowest point on my graph? Now, your eyes might first take you here, but don't forget this is an arrow, which means it goes down forever. So this goes down to -infinity. And it goes up to what? Well, it kind of levels out here, never gets any higher than that line there, which is at +5. So it goes from -infinity up to +5. Does it ever actually reach +5 though? Well, no, it just gets closer and closer to that value. So again, we want parentheses around the 5. Okay? And then the last one, what is the domain and range of our last graph here? So the domain, let's see, what's the smallest x value? Well, that's the furthest left point. There's no arrows to worry about. So it's from here at -6, I think. Yeah, so from -6. And then can x actually be -6? Yeah, closed circle. It means we want brackets. It goes from -6, well, up to here. Then there's a hole there. So it goes from -6 to -4, not including -4. And then we want the numbers bigger than -4 as well, all the way up to, it ends here at x equals 7. Open circle means we want parentheses. So there's the domain, and then the range. Well, what's our lowest point on our graph? That's down here at -4. It's a closed circle, so we want brackets around that. And then that goes up to what? Well, this high point at y equals 6. It's an open circle, so we want parentheses around that. So then there's the domain and range, and that wraps up the second page of the notes. And then the third page is coming up.